Welcome back to everyone. So we would start discussing the key answers for the questions given for you to practice. So we discuss which of the following is an example of a covalent solid. So one of the option given is silicon carbide, second option is barium sulfate, third option is solid carbon dioxide, fourth one is iodine. The word covalent refers to there must be the presence of a covalent bond between them. So silicon carbide has a formula SiC. BaSO4 cannot be because there is a bond present, there is ionic bond, so that cannot be the option. Solid CO2, see, solid CO2 is a molecular solid, there must be the molecular forces among them. Iodine I2 cannot be, there also presence of van der Waals force of attraction, they are molecular solids. The best among silicon and carbene, they belong to 14th group in the periodic table, there must be the covalent bond present between them, so the best option we choose is the silicon carbide. I hope in this question there is no any doubt. Second, which of the following is a molecular solid? Very simple, molecular solid have a molecular forces of attraction. Magnesium oxide cannot be, there is ionic bond. AgCl also ionic bond. CO2 is a molecular solid. Yes, it is a molecular solid. And palladium is a typical metallic solid. Therefore, the question was given is which of the following is a molecular solid? The best example we choose is CO2. Then we move on to the next question. An example of ionic solid is. They are again asking ionic solid have ionic bond, diamond is a molecular, silica cannot be, is a covalent solid, iron a metallic solid, ionic solid is a lithium fluoride. Therefore, in the third question also there is no any doubt. These are very basic question. If you could refer the concept very clearly, then you would get it. Fourth question, the interparticle forces in the solid hydrogen. The hydrogen and hydrogen, they are written as H2 is a typical molecular solid. There is a van der Waals force of attraction between the molecules. Try to understand the question very carefully. It is interparticle, means between these two particles which type of a bond is present. The best example between these two, there is a presence of a covalent bond there. Therefore, the answer is not a van der Waals force, not a hydrogen bond, not a coordinate bond. The interparticle forces in solid hydrogen. The interparticle force is nothing but a covalent bond. Then move on to the next question. So, which of the following is not a property of a crystalline solid? So, crystalline solid, they are asking which is not. Definite geometry is a typical property of a crystalline solid. Sharp melting point is also the typical property. Then isotropy and anisotropy. Between these two there is a lot of confusion. When to use the word isotropy, when to use the word non-isotropy. If you measure all the direction they are same, then they are iso. If they are different, then aniso. Therefore, typical which is not a property of and this compound is, the best example is we go for isotropy. Measure all the angles, they are same. They are nothing but anisotropy. Then move on to the next question. Sixth one, so there which of the following does not belong to same type of a crystal system? Which of the following does not belong to same type of a crystal? Means they are asking which type of a crystal. You have a four types of a crystal system: molecular solid, covalent solid, ionic solid and metallic solids. So quartz, silicon carbide, iodine, diamond. You see, easily you can answer this question. Quartz, SiO2 is a typical covalent solid. Silicon carbide is a covalent solid. Diamond is also covalent solid. The best odd option or a correct option among this is iodine is the best example, where iodine is a molecular solid. The rest three are covalent solids. The number of basic types of unit cell among the crystal. You know already chart given there in the concept. The best example is 7. Like cubic, orthorhombic, rhombohedral, monoclinic, triclinic, these all if you count, they become 7 crystal system. Their possible variations are 14. These are called as Bravis Lightice. Keep it in mind. Next, move on to the 8th question. Which of the following is not a crystal system? Means among the 7, which is not the option. That is a correct, right? Then one we have a triclinic. You heard rhombohedral. You heard, right? Then we move on to the third option there, which is the third option given, tetragonal and isomorphous. See, the word one is isomorphous. What is then the word isomorphous stands for? You know, iso means same, morphous means same morphological features. Two crystals having same morphological features can also be called as isomorphous. But the right option in this question is nothing but isomorphous. Next question, the most unsymmetrical crystal system. As I told you to mark in the concept, the most unsymmetrical, where all angles are not equal and all sides are not equal. In cubic, all are equal. Tetragonal, that are not there. orthorhombic, it is also not there. The most unsymmetrical crystal system is nothing but the word triclinic. It is the most unsymmetrical. All angles are also not equal to 90 and they are not even equal. All sides are also not equal. Then the best option choose for is a triclinic. You can answer this by looking into directly from the concept. Then move on to the 10th question. What does the 10th question says? The unit cell with the crystallographic dimensions, they have given A is equal to B, but B is not equal to C. Right? Alpha, beta, gamma angles are equal to 90. Which of these options? The best option from the direct notes, it is tetragonal only. Next, very easy 11th question. The smallest repeating pattern which when repeated again and again results in the crystal of a substance is called as. Very easily you can answer. This is unit cell. Then I have given a chart during my pick I sent in the WhatsApp group there, which has only primitive brevis lattice. One among that is option is rhombohedral, which has only primitive brevis lattice. As I told, how many brevis lattice are there? Total 14. Then move on to the next question. So there the coordination number of CCP and HCP arrangement of a metal atoms are. See, as I told, CCP and HCP, they have a same. Therefore, the option is 12 and 12. There the coordination number directly given, highlighted in your notes, concepts. There the answer is 12 and 12. This is must remember points. Number of atoms are 4 and 4, but the coordination number is 12 and 12. Next, going on to the next question, 14th one. The number of atoms per unit cell in the body-centered cubic arrangement. This is a straight away NCERT question. BCC, how many you answer? It is very simple. It is 2. Right? I hope there is also no doubt at all. Which of the following type of cubic crystal has a maximum number of atoms per unit cell? Maximum number of atom in a simple cube is 1. That of BCC is 2. That of FCC is 4. Therefore, the answer is 4. That is nothing but what? FCC. Therefore, among the 15 questions, I hope you don't have any problem in answering these questions at all. I hope you have no problem in answering these questions. Move on to the next question. In HCP arrangement, each atom at the corner contribute to the unit cell equal to, wherever it is HCP, CCP, FCC, BCC, simple cube, corner particle always contributes 1/8 to its unit cell. The efficiency of packing 68, if you look into this value, it is very simple. The answer is BCC. 15, 16, 17 questions are very, very easy. When atoms are placed at the corner of all the edges of the cube, the number of atoms present in unit cell. Try to read this point. When atoms are placed at corners, this word you have to remember. Corners of all the edges. See, not at the center of the edges. It is corner. Corner of the edges is nothing but corner only. Therefore, how many corners are there? 8 corners into 1/8 contribution. Therefore, the number of atoms is how much? 1. We tick the first option. That is the right and most accurate option among the all the things. Then move on to the 19th question. What 19th question says? The primitive qubit lattice has a percentage void volume is. They are asking void volume. 52.36 is a percentage occupied. Therefore, void volume, if you subtract 100 from this one, you get the answer, that is 47.64, and very easiest answer. Moving to the number of atoms present in hexagonal closed packing, that is nothing but HCP. As I told, whether it is HCP, FCC, CCP, all are same. They are nothing but the best option is 4. Then the number of octahedral sites for lattice consisting of n atoms. See, what is this n atoms? Octahedral. If n octahedral sites are there, then 2n tetrahedral sites will be there. They are asking number of octahedral sites for lattice containing n atoms. Always remember, number of atoms is always equal to number of octahedral sites. Therefore, can you tell what is the right option for this one? It is nothing but option A. They are n. Next question I told you to solve regarding when I given the answer or the question to you people, right? There you see the radius of A plus is 0.95 angstrom, B is 1.81 angstrom. The coordination number of A plus C is dash. See, I will solve here, creating some notes for you people. Look, what is radius ratio? Radius ratio is equal to radius of cation divided by radius of anion. What is the value given for radius of cation? Radius of cation is given 0.95 whole divided by, what is the radius of anion? 1.81. This is nothing but 1/2. Answer is nearly, you get 0.5. This 0.5 falls in the range of, for the coordination number, how much it is? You have a direct question to be answered, that is nothing but What is the answer? Any idea? That is nothing but answer. Very simple. Coordination number, how much you have? 6, right? That is why I told you once solved that and you